What if the browser automation inside your coding agent could be both powerful and economical with context? In this course, we are going to put two official Playwright interfaces through exactly the same local checkout journey. On one side is Playwright CLI with installable agent skills. On the other is Playwright MCP, where the agent calls structured browser tools through the Model Context Protocol. The task is deliberately practical. The agent must open our Commerce Lab, sign in with a seeded demonstration account, find the Playwright field guide, apply a discount, complete a simulated UK checkout, and prove that the order was created. A green confirmation screen is not enough. We will also require a screenshot, the relevant network requests, console evidence, and a maintainable Playwright test that passes independently. Here is the important point before we compare anything. This is not a scientific benchmark, and there is no universal winner. A single run can be affected by the selected model, the agent host, machine load, cached browser state, and even how the prompt is phrased. We will record only what we can actually observe, whether the journey completed, how many shell commands or MCP calls were made, the elapsed wall clock time, and which artifacts were produced. We will not invent a token count or turn one demonstration into a sweeping performance claim. By the end, you will understand why Playwright positions CLI and skills as a strong fit for coding agents working inside real repositories, and why MCP still makes sense for exploratory automation and specialized agent loops. More importantly, you will be able to choose the interface that suits the job in front of you. Everything runs against a deterministic local application. No real payment is taken, no production account is touched, and every credential shown is test data. Let us begin by looking at what you will build and the evidence you will have when the course is finished. The project for this course is a small but complete commerce application designed specifically for repeatable browser automation teaching. It runs locally at 127.0.0.1 on port 4173, so we are not depending on a public demonstration site that might change its layout, throttle requests, or disappear halfway through a recording. The application has the ingredients of a realistic end-to-end journey. There is an accessible sign-in form, a searchable product catalog, basket state, a discount rule, address and delivery fields, order confirmation, and a downloadable receipt. Behind the interface are local API endpoints for authentication, products, discounts, and orders. That gives us enough surface area to teach user interaction, accessibility snapshots, authentication state, request inspection, network mocking, offline behavior, tracing, and test generation without pretending to place a real order. We will use the seeded account learner at example.com with the demonstration password shown in the repository and the code MCP20. The target product is the Playwright field guide. When the discount is accepted, the expected total is £19.99. A successful order uses a generated identifier beginning with Laby-2026. Those are deliberate business assertions, not incidental styling details. As we work, we will create several forms of evidence. The first is a successful browser screenshot. The second is an accessibility snapshot showing the semantic page state. The third is request and response information for the login, discount, and order calls. We will also record a Playwright trace, inspect console messages, and turn the explored journey into a Playwright test built with resilient role and label locators plus web-first assertions. The repository pins the versions used for this production, including Playwright CLI 0.1.117. It also includes the exact prompts, so you can reproduce the workflow rather than trying to reconstruct instructions from the narration. Because this is a local laboratory, you can safely reset the data and repeat each exercise. That repeatability matters. Good automation education should let you distinguish a tool problem from a changing website. With the destination clear, let us establish the mental model behind CLI and MCP. Playwright CLI and Playwright MCP both provide agent-friendly access to Playwright, but they present that access in different ways. With the CLI, the coding agent operates through shell commands such as open, snapshot, click, fill, requests, and tracing start. A browser process is kept available across those commands, and the CLI writes page snapshots to files that the agent can inspect when needed. Installable skills give the agent focused reference material for sessions, storage, mocking, traces, video, debugging, and test generation. The official Playwright positioning is that this model is well suited to coding agents that must balance browser work with source code, tests, and reasoning inside a limited context window. With MCP, the agent host connects to the Playwright MCP server and invokes structured tools. Page structure can be returned directly as an accessibility snapshot, and actions are represented as tool calls with defined parameters. That is useful for exploratory automation, rich introspection, and specialized loops where a continuing browser context is particularly valuable. There are several practical differences in the versions used here. Playwright CLI runs headless by default, although we will pass headed during demonstrations so you can watch it. Its default session profile is held in memory. Cookies and local storage survive between CLI commands, but the state is lost when that browser closes, unless we select a persistent profile or save storage state. Playwright MCP is headed by default and normally uses a persistent profile, although isolated mode is available for clean runs. The capability model also differs. In CLI 0.1.17, the browser commands for core interaction, storage, network control, testing support, tracing, and video are available through the command surface. MCP always exposes its core capability, while additional groups such as network, storage, testing, and developer tools can be enabled explicitly. Limiting MCP capabilities can reduce the number of tool schemas presented to the model. Neither interface makes a weak test strong by itself. Durable tests still need meaningful assertions, stable locators, controlled data, and independent execution. Likewise, neither interface should be treated as a security boundary. The simplest decision rule is this: begin with CLI and skills when an agent is actively working in a codebase. Consider MCP when direct structured browser tools and an exploratory agent loop are the better fit. Later, we will run the same task through both and compare evidence rather than marketing language. Before installing anything, let us make the environment reproducible. For this repository we use Node.js 20 or newer and npm 10 or newer. We also need Git, a current Chromium-compatible browser, and at least one coding agent host. The demonstrations cover Codex, Claude Code, and GitHub Copilot in Visual Studio Code, but the Playwright CLI itself is not tied to one model provider. Clone the companion repository, change into its root, and install from the lock file. On a fresh clone, npm-ci is the most repeatable choice, because it installs the dependency graph recorded in package lock rather than recalculating compatible versions. Start the application with npm start, then confirm that 127.0.0.1 on port 4173 opens before involving an agent. This simple check separates application setup faults from browser agent faults. This production is verified with at Playwright/CLI version 0.1.17, at Playwright/MCP version 0.0.78, and at Playwright/Test version 1.61.1. Run npx Playwright CLI version and expect 0.1.17. You can also use npm-list to inspect the locally installed packages. Pinning matters because Playwright's agent tooling is developing quickly. Command names, help text, and integration details may change after this recording. There is a useful distinction between following this course and starting a new project. To reproduce the course exactly, use the lock file and the pinned versions. For a new project, consult the current official documentation, choose a known version, and verify its help output before copying commands from any video, including this one. Do not silently mix an old narration with a newer binary. We will invoke the repository local executable through npx. That avoids depending on whichever global version happens to be installed on the machine. A global installation can be convenient, but it is not required for this project. Finally, keep the two terminal responsibilities visible. One terminal runs the Commerce Lab, the other runs Playwright CLI, tests, and agent commands. If the server stops, the automation will fail for a perfectly ordinary reason. Once node, dependencies, the local server, and the CLI version are confirmed, we have a controlled baseline. Now we can initialize the Playwright workspace and install the skill files that teach each agent how to use the command surface. The companion project already lists at Playwright/CLI 0.1.17 as a development dependency, so npmci places the Playwright CLI executable in the repository's local binary directory. Confirm it with npx Playwright CLI version, then ask for npx Playwright CLI help. The help screen is our source of truth for this pinned command surface. Notice that network inspection is named requests in 0.1.17, with request followed by an index for full details. Next, initialize the workspace and install the skill files. For Codex and other agents that use the agent-neutral skill location, run npx Playwright CLI install with the option skills equals agents. Version 0.1.17 creates .agents, skills, Playwright CLI beneath the current repository. For Claude code, run the same install command with skills equals Claude. That creates .claude, skills, Playwright CLI. We install both copies because this course demonstrates more than one host. They contain the same Playwright guidance, arranged where the relevant agent can discover it. A skill is documentation for the coding agent. It explains how to combine commands into reliable workflows. It is not a browser extension, a permission grant, or a replacement for Playwright itself. If a host does not automatically discover the installed skill, tell it to read the relevant skill.md file or instruct it to check Playwright CLI help before acting. The install command also initializes the workspace and checks for a suitable browser. If you need to install a browser explicitly, version 0.1.17 provides install browser with an optional browser name. In the companion project, Playwright Test has its own browser installation requirement as well, so follow the repository setup before running the test suite. Keep the skill files aligned with the CLI version. If the CLI reports that an installed skill does not match the tool, reinstall the skill with the corresponding command. Do not copy a skill from a different release into this pinned project. At this point we have three distinct pieces: the local Commerce Lab, the Playwright CLI executable, and agent-readable Playwright skills. Open the project root in your chosen agent host so its working directory and permissions are scoped correctly. With installation complete, we will first operate the CLI manually. Understanding the snapshot and reference loop makes it much easier to recognize whether an agent is using the browser carefully or merely guessing. Let us open the Commerce Lab in a named headed session. The session name is Commerce CLI and the address is 127.0.0.1 on port 4173. Headed mode is for teaching. It lets us watch the browser, while the CLI itself would otherwise run headless by default. When open completes, Playwright CLI reports the page URL and title and writes a snapshot of the current page state. We can request another snapshot explicitly with the snapshot command. This is not a bitmap. It is an accessibility-oriented representation containing roles, accessible names, text, and temporary references for interactive elements. A sign-in button might receive a reference such as E7, but your value may be different. The safe loop is simple. Take a fresh snapshot, identify the element that matches the intended role and name, act on its current reference, and inspect the updated state. Use fill for fields when you want to replace their value, click for buttons and links, and snapshot again after navigation or a meaningful page update. Temporary references are not selectors for source code. A reference points to the element represented by that snapshot, and page changes can invalidate it. Never paste E7 or any other generated reference into a test file. When we create the maintainable test later, we will use Playwright locators based on roles, labels, text, or an intentional test identifier. Version 0.1.17 also provides generate locator when we want help turning a represented element into locator code. For a large page, the find command can search the current snapshot and return matching nodes with surrounding context. Snapshot can also be scoped to a target. Those options help the agent inspect only the relevant part of a complex interface. A screenshot serves a different purpose. It is valuable visual evidence for a person, but the agent should normally use the structured snapshot to identify interactive elements. That distinction reduces coordinate guessing and keeps the action tied to what the page exposes semantically. Try one manual interaction now. Snapshot the sign-in page, fill the email field using its current reference, fill the password field, and click Sign In. Then take a new snapshot and confirm the catalog heading before doing anything else. That open, snapshot, act, and re-snapshot pattern is the foundation for every workflow that follows. Now we can delegate the complete journey to Codex with constraints and evidence requirements that make success verifiable. Open the repository in Codex from the project root and make sure the Commerce Lab is already running. Because we installed the agent-neutral Playwright skill beneath .agents, Codex can use the guidance that matches CLI 0.1.117. We will give it a bounded task rather than a vague instruction to test the site. The prompt names the session Commerce CLI and the local address. It tells Codex to use only the seeded demonstration account, not to modify the application, and to inspect a fresh accessibility snapshot before using any element reference. The business journey is precise. Sign in as learner at example.com, add the Playwright field guide, apply MCP 20, verify a total of £19.99, complete the simulated checkout for Alex Lerner at a UK test address, and verify both the confirmation heading and an order identifier beginning LAB-2026. The second half of the prompt defines proof. Codex must save a success screenshot, report console errors, and inspect the relevant login, discount, and order requests. In CLI 0.1.17, requests lists the captured traffic, and request followed by its number returns the detailed headers, body, and response for one entry. The agent should report what it actually observes, rather than treating a click as proof that the operation succeeded. Watch the command stream. Codex should open or reuse the named session, read snapshots, use current references, and re-inspect the page after state changes. If it guesses a stale reference or skips the total check, stop and correct the workflow. Agent autonomy does not remove the need for review. After the browser journey, ask Codex to draft a maintainable Playwright test. The test should use resilient role and label locators, web-first assertions, clearly named test data, and no fixed sleeps. The generated temporary references must not appear in source code. Run the new test independently with the Playwright Test runner before accepting it. The final response should be a compact evidence table. Observed result, the command or artifact that proves it, and any limitation. This structure makes unsupported claims easy to spot. Codex is acting as a coding agent with browser access, not as an oracle. The quality comes from a deterministic application, a constrained prompt, fresh snapshots, explicit business assertions, and independent test execution. Next, we will keep those controls constant while moving the same workflow to Claude Code and GitHub Copilot. The browser task should not change simply because the agent host changes. For Claude Code and GitHub Copilot, we keep the application, data, success criteria, and evidence requirements identical. That gives us a fair workflow comparison and prevents prompt differences from masquerading as tool differences. For Claude Code, start from the repository root so it can discover the skill installed beneath .claude, skills, Playwright CLI. Use a fresh named session such as Claude Commerce. In the prompt, explicitly say to use the installed Playwright CLI skill, inspect current snapshots, avoid modifying the application, and preserve evidence. Claude Code will still be issuing the same 0.1 setting commands: open, snapshot, fill, click, requests, screenshot, and the relevant storage or tracing commands when requested. For GitHub Copilot in Visual Studio Code, open the same trusted repository and use an agent-capable chat mode that can run approved terminal commands. The agent-neutral skill copy is beneath .agents, skills, Playwright CLI. Agent host support for automatic skill discovery can evolve, so verify that Copilot has read the skill. If there is any doubt, tell it to inspect that skill.md file and to check npx Playwright CLI, help before running the task. Review terminal approvals rather than granting unrelated access. Give Copilot its own session name, such as Copilot Commerce. Separate session names prevent cookies, basket data, navigation history, and console messages from leaking between demonstrations. If you want a completely clean retry, close that session and delete its stored session data before opening it again. Do not compare prose style or how confident an answer sounds. Compare observable outcomes. Did the order complete? Was the expected total verified? Were the screenshot and request details produced? Did the generated test use durable locators? And did that test pass independently? Record elapsed time and command count only as descriptive evidence from this environment. You may see different reasoning paths. One agent might search a snapshot with find, while another reads the snapshot file directly. Either can be valid if it uses current page evidence and verifies the same business outcome. The central lesson is portability. Playwright CLI provides the browser command surface, while the host supplies planning, permissions, and code editing. Keep the task disciplined, keep the browser state isolated, and judge the artifacts. In the next chapter, we will examine those sessions directly and use the dashboard to observe or take over when an agent needs help. A Playwright CLI session is a named browser instance with its own cookies, local storage, navigation history, tabs, and console messages. We have already used Commerce CLI, Claude Commerce, and Copilot Commerce so that each demonstration has separate state. Pass the session option before a command to address the correct browser. Run Playwright CLI list to see the sessions associated with the current workspace. Version 0.1.17 also supports list with the all option when you need to inspect sessions across workspaces. This is useful when several agents are active and you want to confirm which browser belongs to which task. By default, a CLI session keeps its profile in memory. State survives from one command to the next, but it is lost when that browser closes. Add persistent when opening a session if you intentionally want a profile saved to disk, or use profile with a chosen user data directory. For portable authentication, state save writes cookies and local storage to a file, and state load restores that state. Treat this file as sensitive because it may contain reusable authentication material. Session storage is managed separately and is cleared when its tab closes. Now run Playwright CLI show. The Playwright dashboard displays active sessions with live screencast previews, names, URLs, and page titles. Select a session to see its viewport and tabs. You can take control with the mouse and keyboard if an agent reaches a captcha, a two-factor prompt, or simply needs human judgment. Press Escape to release control and return the browser to the automated workflow. The dashboard is an observation and intervention surface. It does not prove a test passed. Continue to rely on assertions, request evidence, screenshots, traces, and the Playwright Test result for that. Session cleanup is equally important. Close ends the current named browser. Close all asks every session in the workspace to close. Kill all is the forceful option for stale or unresponsive browser processes, not the normal first choice. Delete data removes the selected session's stored data, which is useful before a clean comparison run. For this course, keep demonstration accounts separate from personal browsing and never attach an agent to a sensitive everyday profile. Named sessions make parallel work manageable, while the dashboard makes that work visible. Together, they give you a practical way to supervise browser automation without confusing supervision with verification. With session management in place, we can now make authentication repeatable without repeatedly exposing credentials or accidentally committing browser state. Authentication is where a useful browser demonstration becomes a repeatable workflow. In Playwright CLI version 0.1.117, the default browser profile is held in memory. Cookies and browser storage survive between commands while that session remains open, but the default profile disappears when the browser closes. For deliberate persistence, you have two practical options. Opening with persistent stores the wider browser profile on disk so it can survive restarts. A more portable approach is to save and restore storage state. After signing in with a dedicated test account, run Playwright CLI state save followed by playwright/.auth/user.json. In a later session, run state load with the same file, navigate to the protected page, and verify that the authenticated view appears. Storage state covers cookies and local storage. Do not assume that it preserves session storage. Version 0.1.117 provides separate sessions, storage list, get, set, delete and clear commands, and session storage remains tied to the lifetime of its tab. You can inspect individual cookies with cookie list or filter by domain. Clearing cookies and reloading is also a useful negative test. The application should return to its sign-in screen rather than exposing protected content. Treat every saved authentication file as a secret. It may contain tokens that can impersonate the test user. Keep the playwright/.auth directory in gitignore, never publish the file with the course repository, and use a low-privilege test account rather than a personal or production identity. In continuous integration, create the state through a secure setup step, or retrieve it from an approved secret store. When the same state is reused by Playwright Test, reference it through the storage state option, rather than copying credentials into each test. Always verify a signed-in page outcome after restoring state. A file that loaded without error may still contain an expired or revoked session. The principle is simple. Authenticate once, save only what is required, protect it properly, and verify both the signed-in and signed-out states. That gives the agent speed without turning convenience into a security weakness. Network control turns a happy path walkthrough into meaningful quality assurance. Begin by loading the page and running Playwright CLI requests. Version 0.1.17 lists the requests observed since the page loaded. If one entry looks relevant, inspect it with Playwright CLI request, followed by its current index. Those indexes belong to the present request log, so discover them each time rather than hard-coding them into a workflow. Now we can separate the user interface from an unreliable backend. To replace the product's response, quote the root pattern so the shell does not expand the wildcards, supply status 200, set application JSON as the content type, and provide a deterministic body containing one mock agent kit. Reload the page and take a fresh snapshot. The visible heading and £42 price prove that the front end rendered the intercepted response rather than its normal catalogue. For a service failure, route the checkout or product's endpoint with status 503, reproduce the action, and inspect the resulting page state. The important result is not merely that a request failed, it is that the application presents a useful error, keeps the layout intact, and offers a recovery path. Capture that evidence with a named screenshot. Run route list to confirm which mocks are active, and remove a specific route with unroot followed by its pattern. Running unroot with no pattern removes all routes. Always clean up after a scenario, because a forgotten route can make later checks appear to pass against fabricated data. Version 0.1.117 also supports an explicit offline check. Run network state set offline, reload and inspect the browser failure or the application's offline experience. Restore connectivity with network state set online, reload again, and verify that the normal catalog returns. Put restoration in your cleanup plan even when the exercise fails halfway through. For delays, conditional responses or request body inspection, run code can execute a small Playwright function, but use the smallest mock that proves the behaviour. A good network test has a clear purpose, a controlled condition, a visible assertion, and a guaranteed cleanup step. This is how we prove that the interface handles reality, not only the one back-end response we hope to receive. A professional automation result should leave evidence that another person can inspect. Playwright CLI provides several kinds of evidence, and each answers a different question. A snapshot describes the accessible page structure and gives the agent temporary element references. A screenshot shows the visual result. Run Playwright CLI screenshot with a file name such as checkoutsuccess.png for a named viewport capture, or pass an element reference to capture one component. The hires option records at the full device pixel ratio when small visual details matter. Use screenshots for layout, charts and bug reports, but do not treat a picture as a substitute for a functional assertion. Next, inspect the browser console. Playwright CLI console returns the captured messages, whilst console warning narrows the output to warnings and more severe entries. A screen may look correct, even though its JavaScript has thrown an exception, so checking the console is a valuable part of a smoke test. Reproduce the action and inspect the new messages when you need to isolate one failure. For a complete diagnostic timeline, run tracing start before the scenario and tracing stop afterwards. The CLI reports the saved trace path. Open that trace with the current Playwright Trace Viewer, then inspect actions, DOM snapshots, screenshots, network activity, console output and timing in one place. Traces are generally the strongest artifact for explaining why a browser failure occurred. Video answers a different question. What did the user-facing journey look like? Start with video start and a named WebM file, add markers with video chapter, and finish with video stop. Version 0.1.117 can also display action callouts using video show actions, which is helpful for a tutorial or bug reproduction. Stop those overlays with video hide actions when they would obscure the interface. Name artifacts by scenario and outcome, store them in a predictable output directory, and remove secrets before sharing. A sensible evidence bundle contains the final screenshot, relevant console output, and the trace, with video only when motion or timing adds value. Evidence should make the conclusion independently verifiable, not simply make the report look busy. Interactive browser control is excellent for discovering a workflow, but the lasting product should usually be a maintainable Playwright Test. After taking a current snapshot, run Playwright CLI generate locator with the current element reference and the raw option. Never copy an ephemeral reference such as E5 into a committed test. References identify elements in the current snapshot and can change after navigation or rendering. The generated locator should express how a user recognizes the element, preferably through role, accessible name, label, or an intentional test identifier. Review the result rather than accepting it blindly. If a button name appears several times, scope the locator to the correct article or dialogue so the test describes the business context. Use the CLI session to learn the real path through the application, the required data, navigation, expected state, and likely failure points. Then create a focused test file under the tests directory. Import test and expect from it Playwright/test, navigate with page.goto, perform actions with semantic locators, and finish with web-first assertions. For our Commerce Lab, the important outcomes include the signed-in learner state, the 20% discount status, the exact £19.99 total, the confirmation heading, and the LABI 2026 order prefix. Assert those outcomes directly. Do not assert only that a button was clicked. Avoid fixed sleeps such as wait for timeout. Playwright locators and assertions already wait for the relevant conditions, producing faster and more reliable tests. Keep one business idea per test, give it a descriptive name, and place repeated setup in a fixture or setup project. Introduce a page object only when several tests genuinely repeat the same behavior. Wrapping every locator immediately creates abstraction without value. Once the test is written, run the smallest relevant scope with npx Playwright Test and the file name. Review the trace or report if it fails. Correct the underlying test or application issue and run it again from a clean state. The CLI helps the agent observe and generate useful building blocks. The Playwright Test Runner supplies isolation, assertions, retries, projects, and continuous integration execution. Combining them gives us fast discovery without sacrificing engineering discipline. When a generated test fails, we do not want the agent to guess from a stack trace. A compatible current Playwright Test Runner can pause the real test and expose it to Playwright CLI. Start the failing file with npx Playwright Test, the test path, and debug equals CLI. Notice that debug equals CLI belongs to the Playwright Test command. It is not an option on Playwright CLI Open. The runner pauses and prints an attachment instruction containing a generated session name. Copy that exact value into Playwright CLI attach. The returned instructions show how to address the attached session. Do not script a made-up session identifier because the test runner creates a new value for each debug run. From there, take a snapshot and compare the live page with the locator and assertion in the test. Check console error, inspect requests, evaluate a small page expression, or capture debugstate.png. You are observing the actual browser context created by the test, including its fixtures, storage state, routes, and application build. That is far more reliable than opening a separate browser and hoping to reproduce the same conditions. use step over to advance to the next test action, resume to continue execution, and pause at with a file and line when you need a deliberate stopping point. If the failure is intermittent, start tracing before continuing, and stop the trace after the suspect step. Ask 4 questions in order. Is the expected application state present? Does the locator describe a unique user-facing element? Is the test waiting through a Playwright assertion rather than a fixed delay? And does the console or network log reveal an application failure rather than a test failure? Make the smallest justified correction. A renamed accessible label may require a locator change. A spinner that never disappears may indicate a product defect and should not be hidden with a longer timeout. After editing, end the debug session and rerun the test normally. A pass inside an interactively modified page is not sufficient evidence. The clean rerun proves that the committed code works without manual assistance. Finally, remember that the CLI and the project's Playwright Test version must both support this workflow. If the option is not recognized, check the locally installed runner with npx Playwright Test help before changing the test. Sometimes a separate automation profile is impractical. An application may require corporate single sign-on, multi-factor authentication, an installed extension, or a tab that is already open. Playwright CLI version 0.1.117 can attach to an existing Chromium-based browser, but this is a high-trust operation. The extension route is usually the clearest for an existing Chrome session. Install the official Playwright browser extension, then run Playwright CLI attach with extension equals Chrome. You can name the connection with the session option and use the same session name for later snapshots and actions. The alternative is Chrome DevTools Protocol. In the target browser, open Chrome //inspect/# remote. Debugging, explicitly allow remote debugging for that browser instance and run Playwright CLI attach with CDP equals Chrome. You can also attach to a known local CDP endpoint, but never expose a remote debugging port to an untrusted network. An attached agent can interact with the browser's open pages and inherits the sensitivity of its logged-in profile. Do not attach your everyday profile containing personal email, banking, password manager pages, or production administration tools. Create a dedicated Chrome profile with a low-privilege test identity, close unrelated tabs, and supervise any action that writes data, sends a message, purchases an item, or deletes content. An allowed origin configuration can reduce accidental navigation, but it is not a complete security boundary. The safest protection is a deliberately limited account and environment. Take a snapshot before the first interaction and confirm that the selected tab is the intended one. Avoid saving storage state from an attached profile unless it is genuinely required, because the resulting file can contain reusable authentication secrets. When the task is complete, run Playwright CLI detach. Detaching leaves the external browser running, unlike closing a browser that the CLI launched itself. Disable remote debugging afterwards if you enabled it only for this task. Attachment is valuable when it removes a legitimate authentication obstacle. It should not become the default simply because a personal session is convenient. Separate profiles, clear scope, and human oversight keep that convenience from granting the agent more authority than the test requires. We now have a disciplined CLI workflow, so let us repeat the same Commerce Lab task through Playwright MCP. The project configuration launches npx and the package at playwright/mcp using the latest tag. It uses an isolated browser profile and enables the network, storage, testing, and developer tools capability groups required by this course. A smaller task should enable only the capabilities it genuinely needs. Codex reads the project-level MCP configuration from its approved settings. Claude Code can register the same server command, and Visual Studio Code can load the equivalent server entry from its MCP configuration. Restart or refresh the selected client after changing the configuration, then confirm that the Playwright tools are available before giving the real task. Our comparison prompt remains identical to the CLI acceptance criteria. Open the local Commerce Lab, sign in with the seeded learner account, add the Playwright field guide, apply MCP 20, verify the £19.99 total, complete the demonstration checkout, and prove the confirmation heading and LAB 2026 order prefix. Save a screenshot, inspect the relevant requests, and report console evidence. Do not modify the application. MCP exposes browser operations as structured tools. The model receives an accessibility snapshot containing roles, names, and element references, so it can interact without relying on visual coordinate guessing. That underlying browser capability is familiar. The important difference is how the agent invokes it and how the results enter its context. Make the comparison fair. Use the same model, application version, browser family, viewport, and starting authentication state. Use a clean, isolated profile for both runs. Do not give one approach a detailed step-by-step prompt and the other a vague sentence. Record the wall clock time, intervention count, tool calls, available usage information, and produced artifacts. Check the final page yourself rather than accepting a confident summary. A tool call that returned without error is not the same as a verified business outcome. Keep the security scope equivalent as well. Test accounts, intended origins, and no unrelated personal tabs. When the task finishes, compare the screenshot, accessible state, network evidence, and independently executed test. Both runs should meet the same definition of done. This chapter is not designed to manufacture a winner. It gives us two controlled executions of one realistic task, which is the evidence we need for the comparison. A useful comparison begins with evidence, not a slogan. Playwright's own positioning says that the CLI and skills suit coding agents that need a lean, command-based workflow, while MCP remains valuable for persistent, specialized agent loops. That is a design recommendation, not a guarantee that one run will always be faster. Our first measure is functional success. Did each approach complete the same discounted checkout and prove the same order state? Next, record elapsed time from the prompt to verified completion. Separate setup time from task time, because installing a server once should not be charged to every future run. Count agent interventions and failed actions. A workflow that finishes quickly only after a human rescues it twice is not genuinely more efficient. If the client exposes prompt and completion tokens, capture them. If it does not, say that clearly rather than inventing a percentage. You can still compare the number and size of snapshots or tool results, but label that as a proxy rather than a token measurement. Review the evidence each run created, named screenshots, console output, network details, traces, and a durable test. Then test recovery. Refresh the page so an old reference becomes stale, or change one accessible label in the local application. Observe whether the agent takes a fresh snapshot, finds the updated control, and continues without unsafe guessing. For stronger results, run each method several times under the same conditions and report the median, along with any failures. One demonstration is illustrative. It is not a benchmark. In a typical repository-centered session, the CLI has a practical advantage because commands and saved snapshots can be consumed selectively alongside source code. MCP offers a direct tool interface and can feel natural when the client is already organized around repeated tool calls and continuous browser state. Both ultimately use Playwright browser capabilities, so reliability still depends on good locators, controlled state, explicit acceptance criteria, and honest verification. Present the final comparison table with columns for outcome, time, interventions, context evidence, persistence, debugging artifacts, and security exposure. Mark every value as observed, configured, or inferred. That small discipline prevents marketing language from masquerading as a technical result and lets viewers decide whether your conditions resemble their own. The right choice depends less on fashion and more on where the work happens. Choose Playwright CLI when a coding agent already works in a terminal and repository, needs to balance browser evidence with a large codebase, or must turn exploration into committed tests. Its concise commands, named sessions and files on disk, fit naturally into that environment. Choose Playwright MCP when the client is designed around tools, when a specialized agent needs continuous interaction with page structure, or when a long-running exploratory loop benefits from persistent browser context. Choose attachment to an existing Chrome profile only for a specific requirement such as single sign-on, multi-factor authentication, an installed extension, or an existing tab, and apply the safety controls from the previous chapter. For production test execution, choose neither interactive interface as the final authority. Commit normal Playwright Test files and run them with npx Playwright Test in continuous integration. That runner supplies repeatable isolation, projects, assertions, reporters, retries, and parallel execution. A strong hybrid workflow uses each layer for what it does best. First, let the CLI explore the application, inspect requests, save snapshots, and generate semantic locators. Second, have the coding agent turn the observed flow into a small Playwright test with explicit assertions. Third, run the test normally and use Debug CLI only when the real test needs interactive diagnosis. Fourth, use MCP for a persistent exploratory assistant or a specialized healing loop where that continuity has clear value. The sequence can also begin with MCP if that is the team's preferred client. The important handoff is from conversational exploration to reviewed test code. Apply the same guardrails to both interfaces. Use dedicated test identities, restrict the environment, mock destructive integrations, and require human approval for meaningful external writes. Store traces and screenshots as evidence, but never publish authentication state. In the on-screen matrix, map quick repository verification to CLI, persistent tool-driven exploration to MCP, existing authenticated tabs to supervised attachment, and regression execution to Playwright Test. If two cells apply, use the hybrid rather than forcing one technology to cover the entire lifecycle. The best architecture is not CLI everywhere or MCP everywhere. It is a small, auditable workflow in which exploration is efficient, tests are maintainable, execution is reproducible, and browser authority remains proportionate to the task. Let us finish by combining the course into one Capstone workflow. Start with a clean, named Playwright CLI session and confirm that version 0.1.17 is available. Open the demo application, take a fresh snapshot, and complete the agreed user journey using current element references. Verify the outcome from the accessible page state, not from the absence of an error. Next, inspect the request log and browser console. Add one controlled network failure with root, reload, and prove that the application presents its recovery experience. Remove the root immediately afterwards. Repeat the failure with the browser context offline. Restore connectivity and confirm that the application recovers. Record a named screenshot of the final state and capture a trace around the most important transition. If movement or timing helps explain the result, add a short chaptered video. Otherwise, leave it out. Save authentication state only when the scenario requires it, and keep that file outside version control. Now convert the observed journey into a focused Playwright test. Replace snapshot references with semantic locators created through Generate Locator and Human Review, add web-first assertions, and run the file with the normal test runner. Introduce one deliberate locator fault, launch the test with debug equals CLI, attach to the printed session, and inspect the real paused page before making the smallest correction. Rerun the test cleanly. Finally, execute the same acceptance criteria through Playwright MCP and place the two observed results in the evidence table from the previous chapter. At that point, the Capstone has produced more than a browser demonstration. It has produced a reproducible test, failure coverage, diagnostic artifacts, and a reasoned tool decision. The source repository linked below the video contains the commands, prompts, test file and safe sample configuration, but it deliberately excludes browser profiles and storage state secrets. Because both projects evolve quickly, check Playwright CLI help, your local Playwright Test help, and the official documentation whenever you upgrade beyond the versions shown here. If this course helped you, continue with the linked Playwright MCP deep dive, share which workflow fits your team, and subscribe for the next practical automation course. Most importantly, keep the habit we use throughout. Define the outcome, control the state, collect evidence, and turn exploration into maintainable code.